Hi everyone. So today we're going to be building this blinking light system, and as you can see, we're not using any Arduino, we're not using any microcontroller, or we're not using any code. We're just using transistor, resistor, and capacitor, and our power bank over here. And I'm going to be doing this from scratch together. So stay with me as I'm going to be building this from scratch. So now for our blinking LED circuit, our components and materials are going to be needing we'll be needing a breadboard. This is a breadboard here. We'll be needing NPN transistor. This is an NPN transistor. We'll be needing 2, and this particular type is 2N222. We'll be needing 2 of it. We'll need LED, that means this light. We can use any color. Yeah, I have blue and green. You can bring yellow also, and you can use any color that you want. Just make sure you have 2, because you only need 2, but you can bring the same color but different color. Well, I advise you bring different color so that you can enjoy the flashing of the LED. And we'll need 330 ohms resistor. This is our 330 ohms resistor. We're going to be needing it. This is our 330 ohms resistor. We'll be needing it to protect our lights. We'll need 2 of it, and you will need 2 of 1 kilo ohms resistor. This is for our base of our transistor. And we'll also need 1 of 10 kilo ohms resistor. This resistor here, we need 1 of it to protect for the timing. And we'll also need our 22 UF capacitor. This is it, 22 UF. We will need 1 of it, and we'll need our 5 volts power supply. And this is my 5 volts here for my power bank. I will need our jumper wires. So let's build it together. So the first thing that I'll first do is that I need to explain how a breadboard is. Now you might have seen a breadboard before and be like, what the hell is this white stuff? So now this is a breadboard, and as you can see, it has a lot of holes in it, and it has sections: section A, section B, section C, section D. And don't mind this thing I did here, I'm going to be explaining it. So now in a breadboard, this whole section is mostly used for power rails. This is the power rails. So it means that the whole of this column from here to this exact place, they are all connected together. You can use it as your positive power supply or negative power supply, but in mine I'm using it as my positive. It means, and for this place, this 1 2 3 4 5, all of this column, they are connected together to this place. Why this place? So they're also connected together the same way. You can use it as any line you want. You can use it for your positive, and you can use it for your negative. But this is why I did this connection was that, so that in case if any power is moving from here, to also connect to this place. And the same thing for here. This place is not connected to this place, they are separate. And on some breadboards that are very mini, all these whole places might be connected together. Why for this section, the whole of these rows are together. This row 1 is connected to here. All of these places 2 are together. The same thing here. But these all places that are not connected together. It's only this place that is connected together. So that is how a breadboard is. And the behind the scene is under this part here. All the old pins, if you can look closely, you've seen the pin, the shiny pins inside. That is what is connecting the components under, to avoid them from losing. And our component 1 is our NPN transistor. This is our transistor, NPN transistor. Although you might not be able to see the number clearly. Okay, this is 2N22222. This is a NPN transistor, and in this transistor, it has the base as the middle, it has the collector as this place, and the emitter. Then we're going to be explaining more about it in the video. This is our light also. This is our LED. This is our LED, our 330 ohms resistor. I've explained it. So the first thing we'll first do now is to try to turn on a LED first. Because some of you might have seen a breadboard before and don't know how to turn on a LED. So what I actually did was that this is our jumper wire. This is another type of jumper wire also. So since this place is going to be the negative of my power supply, I decided to jump the power supply from here to this row, from here to this place also. So now let's turn on our blue light. Now you might have been seeing in a lot of electronics, you might have been seeing bunch of resistors and be like, what the hell are this guy doing in a circuit? Now this resistor is actually to protect our electronics from getting damaged due to high currents. So the function of a resistor is actually to limit or reduce the speed of current, or reduce the flow, or limits the flow of current, anyhow you want to put it. But just know that a resistor helps to limit the flow of current in a circuit. Although I don't have a spare leg to sacrifice for this video. If not, I would have demonstrated how a lead will get burnt instantly without a resistor. But for the fact that some people might want to subscribe, let me try to sacrifice one. So let's try to sacrifice this lead first. So let me first test it if it's actually working with a resistor. So let me see if it's working, because I doubt if that lead is still okay. At this point in time, I might use the resistor because I want to protect it first. I need to see whether it is still alive before I can start the sacrifice. So this is going to be my power supply. And this is my power supply. This is the negative of my power supply. Sorry, it does not have the red and black wire. So let's see if this is actually good. Okay, the light is still working, but I don't know if I still have another extra yellow light. But let me sacrifice it. And that's what's going to happen with a resistor. The light still turned on, but let's see what's going to happen without a resistor. This is going to happen without a resistor. Without a resistor, let's see what's going to happen. Can you see? The LED turned on at first, but now the thing has gotten burnt. And if you see it, you can see fire is coming out. The reason fire is coming out because of this foolish LED have burned. And it's dead already. So that's the function. If you can see the inside, you see a black thing there. If you can see it, that's the function of the resistor in our circuit. Resistor is to help us to limit the flow of current. If not, more and more of our leg will continue burning, and we'll start buying more again. So that's by the way. For that sacrifice now, I pray you subscribe and like the video. So let's test it with some precautions. So I want to turn on this blue light first. I'm going to connect it the right way. But how am I going to know the right way? Some of you might not be playing with it. That okay, let's try it like this. Let me try it the right way and see whether it's going to on. I don't know whether it's going to on, but let's see. Okay, let's see whether it's going to turn on. And okay, turned on. And the reason I turned on because I actually know the right pin. Let me turn it the other way around. Get it not turned on. Now, how are we going to see the correct way rather than doing try your luck while building your circuit? This is how you know it. If you look at it, you see that the two pins are different. So one is longer, one is shorter. So this longer one is actually the positive of the light, while the shorter one actually the negative of the light. That's why you see it. You see, let me connect it the way I said earlier. You can see it's turned on because I connected the negative to the negative and the positive to the positive line. If I do it the reverse way, can you see don't turn on because it is in reverse biasing mode, or I connected in reverse way. And though sometimes you might have been using your LED for centuries and the pins are going to be equal, you now be like, how the hell will I differentiate between the positive and the negative? Will I have to be doing trial by error again? No. Actually, if you look closely at the LED, I don't know that I might be able to see it clearly, but if you look closely, you'll see something. For this pin here, look at this place is very big. This inside plate is big, but for here it is very tiny. But to cut the story short, this place that has the tiny pin is the positive, While this one that have the biggest pin is the negative. Another way is this. If you look at it, you see that this place is flat. This flat place is the negative. This flat place is negative. While this one that is round is the positive. But let me draw what I said was inside. This is it. This is it. This is what is inside the lead. Something like this. We're having something like this. This one that has the positive, this one that has the biggest plate is the negative. While this one that have the that is kind of small. You might see it in real life if you are holding a real LED, but you might not be able to see it from this video because of the camera. Same thing with other LEDs also. Short distance. So that's how I'm going to be able to identify the positive and negative of my lights. So let me connect it the right way. So let's see. Okay. So now the thing has turned on. Now let's do the same thing for this green. Because on this project we're going to be blinking green and blue lights. So let's do the same thing. And let us make sure you are using your resistor. Because you saw what happened to the previous innocent yellow light. It got burnt. So let's see what's going to happen. Now the two lights have turned on. And this is the circuit diagram for what we just did now. This is the circuit diagram here. We have our lights, the power bank that went off. That's why the lights went off. We have our lights here. The negative was connected directly. The negative of the light was connected directly to negative of our battery. This is the symbol of negative of battery. It's only shorter, but the longest one is positive. But it was connected to a resistor to protect it from getting damaged. And with that, our lights turned on. Same thing for this one. But that is just the first and interesting part of this our blinking LED circuit I want to do. So the next one I want to do is I want to introduce our transistor. And actually, if you go to the market, you might not see this exact type of transistor. You might not see this 2N222, but it's mostly common. But if you see any type of transistor, maybe C1815, BC547, SS8550, any type of transistor that you see, before you use it, you can go to Google and type the name of the transistor and go to see the data sheet. What you only need is to know which pin is for the base, which pin is for the collector, and which pin is for the emitter. Because for this 2N222, this transistor, the base, this transistor has 3 pins. It has 3 pins. The place facing you, actually the place where the name is written on. That way we're going to start looking for the missing B or C or E. So now in this transistor, it is something like this. The name is here 2N222, and it has this pin 1, 2, 3. This place is the emitter. This middle is the base, and this last piece is the collector. Why this guy is facing you, not with this round back. We're looking at this flat side. This flat side where they wrote the part number. So if you go to Google for C1815, it is opposite. For C1815, this place is the emitter, this is the collector, and this place is the base. So that's why I say that if you want to use your transistor, if it's not 2N222, always look for the name so that I can follow our circuits correctly. So with this, we can now do our project. So this 2N222, make sure the emitter is connected to the negative of your power supply, and the collector is connected to the positive of your power supply with the help of this resistor. So you connect it like this. Now if you look at it, you see that at this middle empty space, the base is sitting now at that place. If you look at it closely, and the resistor is connected to this LED and connected to the collector. And as I said earlier, in a breadboard, the whole of this place are what? Connected together. Now let's what's going to happen. Let's do it in this other place also. Same thing, dip it in. So let's power on our supply and see if anything going to happen. Okay, nothing actually happened. It was the same way the LED was running that is actually still running again. So let's turn it off. So now what do you need to do now? A transistor is just like a switch, but it's just that it is different from manual switch that you have to turn on by yourself. It's different from a manual switch, because a manual switch requires mechanical stuff. Different from switch like this. This is just a manual switch. Although I'm using the practical just for explanation. But this transistor is also a switch, but a switch that works when it receives signals and other stuff. Maybe they are building some kind of cool project. So now, as I said earlier, a transistor has what we refer to as the base. So this base is where the signal is going to get in and say that, hey boy, let's current flow. Hey guy, don't let current flow. So because of the base is actually the operating room of the transistor, we need to protect it with our resistor. So it means that this base, you connect a resistor there. Now I'm using 1 kilo ohms resistor. You connect it to the base of your transistor. Connect it to the base of your transistor. I've done that already. This is the resistor here. So do the same thing in this place. Oh, sorry. Do the same thing in this place. Connect it there also. So let's see whether any interesting thing is going to happen. Okay, nothing actually happened. Okay, so this is what we have actually done right here. This is what we have done. We have connected the LED, which is the light, and we have connected it to our transistor, and we connected it to our resistor for A, and we did it also for here. The resistor to protect our light was 330 ohms, and the resistor to protect our base is 1 kilo ohms. So now let's continue in the next step. Now it is now time for us to make the light start its magic. So now what is going to happen? Take this your jumper wire, connect it to the collector. That means this place. Connect it to this collector. That means this place here. Your jumper wire. Connect it here or connect it to this LED. Just make sure you connect it to the collector of transistor 1. Then pick it and you give it to the base of this light 2. But before we put it to the base, let's see what's going to happen if we turn it on. Now you can see the light turn on. But since I said that the base of a transistor is actually where the signal is going to come into, so let's see what's going to happen if we give it a signal. That's what happened. When we gave the base of transistor 2 a signal, what did it do? It didn't turn off the light. That means when we did this setup, when we took it here and connected it to this place, the thing did what? The thing killed. No, sorry. The thing turned off the light. So for the practical, we're going to make sure this light is going to turn off. So we have done this part already. We have done this part already. So I've done connection of this to kill this light. So it now remain this guy and this guy. Now you might be seeing 2 capacitors. This will actually use 2 capacitors here. In the main project, I'm using 1 capacitor, and I told you to get 1 capacitor. But I also want to show you guys something fascinating after we're done with the project. So stay with me. So now let's do this guy. Now if you can see in this circuit diagram for the capacitor, this symbol of a capacitor, I said this place is the negative. Please, I'm going to connect it to the positive. But it might be like, where on earth are they writing positive and negative on a capacitor? Now if you look at this capacitor, you'll see this sign, and you see that it's different from here. If you look at this guy also, if you look at this guy also. You see here and you see this place. So this place with this stripe or odd stuff is the negative. Same thing as here. It's the negative. But there are some capacitors that don't have this kind of boring design. Those capacitors are non-polarized. That means you can connect it anyhow. We don't care. They don't get damaged easily if you connect it wrongly. But this one, you connect it anyhow, it might overlook your wrong connection, and before you know it, poof. I don't know, sure, but it's gonna get damaged if you connect it the wrong way, bit by bit. So now let's follow our circuit diagram. Now circuit diagram actually tells us that the negative of this capacitor is getting connected to the base of transistor 1. So let's say we have this resistor here, so we're connecting it here. I'll connect it to any place you like. So I've connected it from here. Can you see from here to here? We've connected it. So I've done what? Okay, sorry. So I've done what the circuit diagram said. Connect the negative to here and leave the positive out. Now the positive is now going to be connected to where? Going to connect it to this guy over here, to the collector of transistor 2. But how do we do it? We cannot just fly it or pull out the pins. So we're going to be calling our guy to help us, which is our jumper wire. So connect it here. And this is why connecting it here is that, as I said earlier, the whole of this place are joined together. So me putting this jumper wire here or here, same thing as me joining them together. I take it to where? Take it to this guy. Although there's no space, so you can start it. In yours there might be space, but in mine I was stingy enough not to leave space. So now I've done that. So that's what's going to happen with that. Same thing, nothing fascinating happened. But my circuit said the light was blinking. What was wrong? Okay, let's remain this guy. So we need this 10 kilo ohms back. So now let us introduce our 10 kilo ohms. Okay, this is our 10 kilo ohm here. This is our 10 kilo ohm resistor. And what did the diagram actually say? The diagram said this 10 kilo ohms is connected to the negative of the capacitor, or also to the base of this transistor, since that is the same thing, and it's connected to the collector of this same transistor. Looking for trouble. So what that actually means is that although there's not enough space for us to do our stuff, so for mine, since I'm stingy with space in this my circuit, I'm going to do the first thing. Connect my resistor here. I've connected it here. I've done it already. Can you see? So this last space, I'm connecting it to this place. Although there's nothing there, so then I'm going to be using my jumper wire to help us temporarily connect it to this place. But it's going to be looking a little bit messy. It might be disturbing this resistor. But don't forget that this same jumper wire from this collector is connected to this place. This same thing. So it means that whatever is here is same thing as here. Rather than disturbing this guys over here, I can just put it here. So it's still the same thing. So it's still the same thing as connecting it here, or I drag it and connect it here. So I've already connected my resistor, and let's see what's going to happen. Okay, so connect my this. Oh, the magic actually worked. So can you see what actually happened now? So you can see that the light is already blinking. Light is actually blinking because of what? Because of this circuit diagram. So now let me explain the why behind this, because there's no any code to say delay 1000, delay 2000, just transistors and some stuff. Now let me explain what's actually happened here. Please, if you are not interested in boring calculations and knowing some kind of phases that might look distracting in the video. This is just the end of the project. You can skip the video, but in case you want to know the why behind how this thing work, stay to the end of this video. What is actually happening is that something like a tug of war is happening here. Tug of war. Tug of war meaning that only one must turn on. Either this guy on or this guy should turn on. Now, we all know that if a transistor should turn on from this our setup, the light is going to turn off. And we made this circuit B. We made this transistor B or circuit B turn on very fast because we connected it directly straight. When it turned on, what happened? The lights turned off. But when the lights turned off, the voltage at this place went close to 0 volts. Now, the moment the voltage went close to 0 volts, the voltage at this capacitor also was close towards 0 volts. With that, the team put this capacitor to a negative voltage. Why did they put to negative voltage? Because the team want to make sure that the difference between the voltage here and the voltage here should give like 5 volts. On the norms, the difference between the voltage here minus the voltage here. That means the positive of the capacitor minus the voltage in the negative capacitor was somehow like 5 volts. Because we're supplying 5 volts here. But when this guy went to 0, the thing has to move towards minus 5 volts so that this circuit can still become balanced. So with that, since it was at negative voltage, and a transistor need at least 0.7 volts or 0.6 volts to work, what actually happened? That negative voltage cannot turn on this transistor, and with that, this light was happily turning on, nothing to turn it off. Why this one was suffering from turning off? Because it's already getting at least 3 volts, which was able to turn it on. So this 10 kilo ohm resistor was silently charging this capacitor back. So the moment it was charging it back, from minus 5, it went to minus 4, then went to minus 3, minus 2, minus 1, then went to 0, then from 0, it went to 1, and so on. So between that 0 and 1, we have around 0.7 volts. So when it quickly reached 0.7 volts, what happened? It turned on this transistor, on it. And what happened after turning on the transistor? It turned off these lights. After turning off these lights, the voltage here went to 0. After the voltage here went to 0, this guy was not able to turn on this transistor again, and these lights turned on back. So from that, the circle started repeating itself. Till then, we now have this blinking light circuit. And it actually has a formula. There's a formula to determine the time. C is equals to, I think, RC. So it means that the value of your resistor, this 10 kilo ohms, times the value of our capacitor, which was 22 microfarad. So that was what make the timing to be determined. Although in real life, it might not be like that. So what's going to happen is that if I increase the capacitors, the timing is going to what? Also increase. So let's see if it's actually right. Here, our capacitor was 22 UF. So here I'm going to be using 220 UF. So let's say connect it direct, and so this guy. And this was going to happen. So this is what happened. Can you see what happened? Can you see that the timing actually did what? Timing actually reduced. And that was because of what? That was because of we increased the capacitance. So the fact that we increased the capacitance the timing did what? Timing increased. So with that, that's now made our light started blinking like something. So we can change it back. Bring back the lower capacitance and do it inside. So come to that, it is now very fast now, and this is the end of our blinking LED circuit. Sorry guys, I just realized something in the diagram when I was drawing it. This place was actually the negative of the light. That's not the positive of the light. Due to the fact that I was forgetting some things, but this is how the thing is meant to be. It's meant to be like this actually. This is how the thing is meant to be. All these old diagrams that are here. But the explanation is correct. But I just discussed about the diagram for the LED symbol. So it's supposed to be like this. This space is the positive of the light. This is the negative of the light. So sorry if you actually thought it was a mistake. And the same thing for here also. The same thing for here also. It is meant to be like this. Not like this. But the diagram is correct. The positive of the battery to this place and the negative of the battery to this place. And that is to show you that no one is above mistake in electronics. So if you try this project out and the thing did not work, try to calm down and do it again. It might actually work. Because I didn't even realize the mistake. I just realized it now. So that's why I'm trying to do the correction. Same thing for this place, the symbol of the LED. On the norms, if you do the practical, it's gonna be right, but the symbol of the LED might kind of look confusing. So that was why I decided to correct it now. So this is the main circuit diagram that I just decided to redraw now. I've corrected the symbol, but as you can see, they are the same thing. It's just the symbol of the LED that made it look different. And thanks for your understanding. But just know that in every electronics project there might be some mistake that you might encounter, but don't think it's a problem. It's just a way of electronics welcoming you. And don't forget to like and subscribe to my YouTube channel, as I'm not going to be doing more projects but also explaining the why behind it. And thanks for watching the video. And also, I have an academy where I teach and explain electronics and stuff like this. So in case you might be interested, type "I'm interested" in the comment section, and I'll see you in my next class. You can build this also, because you can see that there's no any microcontroller or any code or any IC, just pure electronics logics. So thanks for joining the class, and bye for now.